Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about 8086 registers. Look at this. First thing we are going to see about the segment register. So first segment register will be a code segment register. Look at this. So we have a 4 segment register. So this is the under control of BA unit, code segment, data segment, stack segment and extra segments. And then instruction pointer. So this is an offset registers. Look at the first one, code segment register. This is the 16-bit register. So we can call it as a CS. CS means code segment. Why it is called code segment? So the program will be stored here. The program code, that code will be taken as a name, code segment. So this code segment contains the base or starting address of the code segments. So whenever we have a tabulation, we have a starting address and offset address. So this code segment holds the value for a base address, that is a starting address. Look at this. So if you use this instruction pointer, so this will be used for the offset address. So IP holds the value of offset address. So by combining these two only, we produce a physical address. So BA unit, we need to generate a 20-bit physical address. So how it will be done means, we take this code segment value and left shift logically 4 times, or that will be equal to multiply with the hexadecimal 10, or we can multiply with the decimal 16. So all the 3 gives the same results. So that means if you shift left 4 times, it inserts 4 zeros. Or if you multiply with the hexadecimal 10, it also introduces the same option, that is a 4 zeros will be introduced. Or if you multiply with the decimal 16, that's also equal to hexadecimal 10, it also adds 4 zeros to the code segment values. So before multiplication, so code segment will be a 4-digit value, that is a 16-bit value. After left shifting or multiplying the values, it becomes 5-digit, that is a 20-bit value. So it becomes a 20-bit address. After that, the instruction pointer value that will be added with this value. So after left shifting 4 times, the instruction pointer will be added, and then the final physical address will be generated. So this particular location only access for the program codes. Look at this second segment register, data segment register. It also a 16-bit register. So it points the data segment, and this is the whatever the data we are accessing. So this data segment register will be used to access that. So this 16-bit register, so we need to use a source index or destination index as an offset register, because whenever you are generating a physical address, we need both base register and offset register. So we take this data segment register and multiply with the hexadecimal 10, or we can perform equivalent like an left shift 4 times, or multiply with the decimal 16. After that, that offset address SI, DI or a base pointer, any one offset register will be used, and that value will be added to produce the 20-bit physical address. So next will be a stack segment register. It is also 16-bit register. It will be used to indicate the top of the stack. So here also the starting address will be holded with the stack segment register, that is SS register. Again, whatever we are doing, so whenever we are pushing a data to stack, so this will be a stack pointer will be points that offset address, and stack segment will be points that base address. So what we do, the stack segment into hexadecimal 10 and plus stack pointer, it points the final 20-bit physical address. So whenever you are pushing a data, this physical address will be used to store the data. Whenever you are popping the data present in this 20-bit physical address, data will be retained. So normally we use a stack pointer for accessing that offset address. Also we can use a base pointer for accessing that particular values. So offset register, so SP or BP will be allowed for this segment. Look at this next one. This is extra segment register. It is also a 16-bit register. It is also used to store the data. So whenever you are accessing the data, so extra segment into hexadecimal 10 plus DI register will be normally used to access the data. So what is the need for 2 segment for data? So whenever you are performing string operations, we have a source string and destination string. So for that we need to have 2 different locations. So the one is for a source location and another one is for the destination string location. So for that we need to use this code segment and SI for a source string, and destination index and extra segment for a destination strings. So whenever you are performing a destination, that is a string operation, we need to use only as a stack segment and extra segments. So these segments will be used to access the destinations. Next will be a instruction pointer. So instruction pointer will be used to point that locations. So it is an offset address, 16-bit offset address. So the code segment register into 10 plus this instruction pointer. So it's a memory, we can say it is as a memory pointer. So whatever the value is present, so these physical location program will be executed. So this will be most important to access that. So it automatically indicates for the next instruction, because whenever we have the instructions or program codes, so these will be stored in a consecutive locations. So to access that, the instruction pointer will be incremented continuously to get the next codes to execute. Thank you.